is given to you or functional point value is given to you, that point value you will use and you will calculate these things. You will get a numerical value of this for the given numerical data. And you just see, if I will take interchange or take common minus in numerator and denominator, then it will be f of x0 by f of x0 by f of x0 minus f of x1 by x0 minus x or x1. Or if I will rearrange this term, it will be looks like this. Okay, f of x0 by x0 minus x1 plus f of x1 by x1 minus x0. And if I will interchange the position x0 and x1, the result will be the same. So place interchange with respect to the argument, its divided difference will give you the same value. Means theoretically it is known as it is symmetrical with respect to its arguments. Same result you will get if you will interchange the position. Any two points, if you will change or interchange, the result will be the same. So 3 value, if you will rearrange, its difference will be first divided difference of x1 x2 minus first divided difference of x0 x1 by x2 minus x0. And this is, you just write down in this form like this or like this, and below this is x2 minus x0. And after doing this rearrangement, it looks like this. F of x2 by x2 minus x0, x2 minus x1, f of x0 by x0 minus x1, x0 minus x2, f of x1 by x1 minus x0, x1 minus x2. So you just see any term addition, these all three terms are addition. So any term I can able to write in first position, second position, or third position. Means with respect to addition, place interchange, means it's satisfying the commutative property. So value is same. So any value if I interchange, I will get the same value. Okay. Now, and these differences value we will use from the first difference formula. Okay. So you may able to calculate second difference. After getting second difference, it will be used here and here to calculate third difference. So with the help of step-by-step differences, we may able to calculate higher differences also. For the given set of data points, how it will be calculated, that is you just see here. Suppose discrete data points x and y is given to you, and you have to calculate here is also difference table. So functional value means functional value, this is actually f of x1, f of x, y equals to f of x, f of x1, this is basically f of x0. So f of x1 minus f of x0 by x1 minus x0, that is f of x1 minus f of x0 by x1 minus x0. That is first divided difference between two arguments x0 and x1. That is by in the definition of the operator I told you. Okay. So logic is, if you will subtract y0 from y1 and divide by x1 minus x0, you will get first divided difference between two arguments. Put that value in this place. Okay. Again, you just subtract y1 from y2, divide by x2 minus x1. You will put that value, that is the first divided difference between two arguments x1 and x2. Similarly, between two arguments xn minus 1 and xn, you may able to calculate first divided difference. Subtract yn minus 1 from yn, means this value, divide by xn minus 1. And that is the last value of the first divided difference in this column. So you may complete in this way the first divided difference column. After getting first divided difference column, again you just subtract this value from here and subtract x0 from x2, this formula. Then subtract this one from here, divide by x2 minus x0, this formula. That is the first value of the second difference. First value of the second difference. Again subtract this value from the next value here and divide by x3 minus x1. You will get here a position. In that way, again subtract this position value from here, again subtract this from here, you will get this position. In that way, you have to complete second difference column. And here is also you have to complete. Logic is looks like the forward difference table, but here in denominator you have to divide some arguments result. Okay, some value. Otherwise, it is looks like forward difference table. After completing, actually in this way, or with respect to n plus 1 points, you may able to calculate up to nth difference. And after completing that, you have to pick up his upper diagonal elements here is also. First value is y0, second value is this, third value is this. In that way, step by step, upper diagonal elements will come, and that upper diagonal elements will help you to construct here the polynomial. And that polynomial is known as the Newton's divided difference interpolated polynomial. Okay, and I think you are aware about this, and if you are not still you not able to understand, then you can ask. So suppose upper diagonal element, first element y0, then it will be f of x0 x1, then f of x0 x1 x2, then next value will be f of x0 x1 x2 x3, next value will be f of x0 x1 x2 x3 x4. In that way, last value will be looks like this. Okay, first value, second value in the difference table. These are the upper diagonal elements. Third value, and this is the last value in the difference table in upper diagonal. Associate coefficients in first term, it is multiplied by 1. Here is 1. Second term multiplied by this factor x minus x0. Third term x minus x0, x minus x1. Next term x0, next term will be x minus x0, x minus x1, x minus x2. In that way, in last term, it is multiplied this factor. Actually, this factor is n linear factor is multiplied. 0 to n minus 1 means n factor is there. N linear factor you are multiplying along with this numerical value. That will be the numerical. If you will, for the given numerical data, if you will calculate the difference table, this will be the numerical. Along with this value, you are multiplying n linear factor. So you will get with the help of n plus 1 points a nth degree polynomial in this technique. Okay. Is it clear? Students, you just see this formula. Try to remember this formula. See this formula and try to remember this formula. Is this formula clear?
Yes, sir.
Let's try to come here a numerical example. Okay, then I will tell you little bit another thing. Okay, this example is given to you. You see here there is an example. Okay, in this example, actually x data, this information x and y data will be given to you. With the help of these data sets, you have to calculate values of y at values of y at x equals to 8 and values of y at x equals to 15. That x equals to 8 and x equals to 15, y value is not given to you. That is, you have to calculate or create, or you have to interpolate. Calculate, create, or interpolate, all are actually synonyms, same words. And that is why these are the interpolation techniques. Okay. Interpolating means creating. Okay. Now, somebody you may ask, we have studied, means we have done Newton forward, backward. Why need to study these techniques? And tell me, can we able to use Newton forward or backward for these values, to calculate these values? Suppose these data sets, are you seeing this example? Students, are you seeing this example?
Yes, sir.
अब बताओ, ये हम न्यूटन फॉरवर्ड जानते हैं, बैकवर्ड जानते हैं, और can we able to use that two techniques for this example? Yes or no? Any important points I told you during that techniques when we are studying that techniques? Any important points I told you about that techniques? Is it clear or not? Actually, that two techniques is applicable for equal space arguments. That is the main logic. Equal spaced, that equal space for x arguments. X arguments should be equispace. If it is equispace, you may use Newton forward or backward. Beside also you may use, no problem. But age is not fixed, so how we will calculate the difference table? Because in that formula, age is very crucial, very important thing. It should be constant. Okay, so since age is not equal here, and that is why related to whatever the age value is coming in every term, we are dividing in denominator something. Okay, so if x values are not equal space, suppose in this example x values are equally spaced, you see difference of these two, difference of these two 1, but difference of these two 2, difference of these two is 3. 10 minus 7 3, but 7 minus 5 is 2, 5 minus 4 1. So x values are not equally spaced. So logically we cannot able to apply Newton forward and backward. Okay. Logically we cannot able to apply that two techniques. So only one technique is now remaining. Simply you are learning this technique means you have to use Newton divided difference or nothing else. And last techniques we are going to study in some remaining classes. Okay, that is Lagrange's interpolation. That is also applicable for the uneven space arguments or unequal space arguments. But that is I will tell you in next class. Okay. First of all, you just tell me why and when these techniques will be applicable. It is clear or not? So obviously we will use here Newton divided difference interpolation. Is it clear?
Yes, sir.
Okay. So now you just construct the divided difference for this numerical example divided difference table, and then we will pick up the upper diagonal elements. Okay. So I told you, suppose actually this is x0, this is x1, this is x2, this is x3, this is x4, and this is x5, and that this one I told you, this one, that is you have to remember. And these underlined black values, this is one, this one, this one, in the difference table upper diagonal elements. So you have to construct the difference table for the given set of discrete points. Construct it. So for this example, you just divide, subtract 48 from 100 and divide by 5 minus 4. Okay, subtract 48 from 100, 48 from 100, this value, divide by 5 minus 4. This is 52, isn't it? Is it clear? And somebody who follow me, subtract to calculate this value, subtract 100 from 294, divide by 7 minus 5. So it will be 194 by 2. 194 by 2 means 97. Subtract 294 by 900 and divide by 7 minus 10 minus 7. This will be 202. So in that way, can you able to complete the first difference column? Process is clear or not? Because after that, I don't think we will solve too much numerical example. You just try to understand nicely. So to calculate, similarly to calculate the last value, subtract this one from here, divide by 13 minus 11, and that will be 409. In this way, 52, 97, 202, 310, and 409 are the first difference column. After getting first difference, higher differences using the previous difference, we can able to use or calculate the higher differences. So to calculate second difference, I need first differences values. And how it will be calculated? Subtract 52 from 97, divide by 7 minus 4. Okay, 97 minus 52 by 7 minus 4. It will be 15. Is it clear? Subtract 100. Suppose to calculate 21. Suppose subtract 97 from 202 and divide by 10 minus 5. Subtract 202 by 310, divide by 11 minus 7. You will get this one. And subtract 310 from 409 and divide by 13 minus 10 means 3. You will get 33. Means 99 by 3 means 33. Okay.
Sir, can you repeat this process again?
This column.
Sir, second difference.
Second difference. To calculate the second difference, you need the first difference column. Okay, as like a forward difference table you have calculated, looks like same, but in denominator, what is you are dividing, that is you just nicely keep in mind. Okay. And before that, basically you just come back into the definition. Second difference of 3 arguments you are going to calculate. Okay. So first difference between these 2 arguments, it will come as in previous column. For the discrete data sets, it will come from previous column. Next value minus this value by in the next position x value minus this position x value. Okay. So divided difference of these 2 minus divided difference of these 2 by last value minus first value. And that logic I am using here for this numerical example. You just see here. First difference column is clear. So in first difference 2 value 52 and 97 is there. So next value is 97. 97 minus 52 to calculate 15 suppose. 97 minus 52 by 7 minus 4. 7 minus 4. Is it clear? To calculate this value 21, subtract 97 from 202 and divide by 10 minus 5. Similarly, in previous column, subtract 2 value means next value minus this value, and in x arguments last value minus first value. Similarly, to calculate last value, you just see, subtract these two means 409 minus 310 by 13 minus 10. So it is 99 by 3 means 33. Is it clear?
Yes, sir.
Now you just calculate third difference column. To calculate third difference column, actually with respect to 4 arguments, with respect to these 4 arguments, you need third difference first value here. So to calculate this one, you need previous difference column, next value minus this value, means 21 minus 15. 21 minus 15, you have to divide last value, means 10 minus 4. 10 minus 4. Okay. And to calculate this, 27 minus 21 by 11 minus 5. And to calculate this, actually 33 minus 27. 33 minus 27 by 13 minus 7. All three value are 1. Is it clear? And fourth difference, to calculate fourth difference, I am subtracting this value from this, means 1 minus 1. And whatever the division I will do means 11 minus 4. That division I have to perform. In denominator it will be 11 minus 4, but in numerator it is 1 minus 1. 1 minus 1 means 0. Here is also 1 minus 1, 0. So whatever denominator it is 0. So fifth difference also 0 minus 0, 0, and in denominator it will be 13 minus 4. Okay. So one logic I would like to clear here. With you are seeing how many points are given here? 6 points. Is it clear? 6 point is given to you.
Yes, sir.
And what is the scientific logic with respect to 6 point maximum? How many degrees of polynomial you can able to construct? If the points are in nonlinear position, with the help of n plus 1 points, you can able to create nth degree polynomial. So suppose you do have 3 points. 3 points are nonlinear position here, here, and here. So with the help of these 3 points, you are joining these 3 points, you will get a second degree polynomial. Second degree polynomial is parabola. So you are approximating a polynomial parabola, looks like that. So if all the points, all given discrete points are in nonlinear position, if you will try to join them, your curve will be with the help of n plus 1 points, nth degree polynomial. Okay. So logic is with the help of 6 points, you may able to construct maximum 5 degree polynomial. But here you are getting the fourth difference column is constant. So these differences are having the linear relationship along with the derivative operator. So as like as fourth degree polynomial, its derivative, fourth derivative is constant. Or third derivative is constant, fourth derivative is 0. That is, you know, third degree polynomial. Suppose third degree polynomial, suppose phi of x is x cube plus 2x plus 3 plus 1. Suppose whatever it is, if you will do it is its derivative, third time derivatives, what it will be? first derivative, its first derivative will give you the second degree polynomial. Second derivative will give you the first degree polynomial, and third derivative will give you the constant value, means that is 6. So phi triple dot x equals to 6 constant, and phi 4 will be 0. Is it clear?
Yes, sir.
So these differences, forward, backward, and divided differences, having the linear relationship along with the derivative operator. So once you will see third difference column is becoming constant, so maybe 6 point is given to you, you will get only third degree polynomial. Because when I am going to construct the polynomial, and if I will pick up the upper diagonal elements, these upper diagonal elements, and when I will multiply this term along with the higher linear factor of the polynomials, these terms will be 0. And so obviously I will get lesser degree polynomial. So in these data sets, it will not reach the maximum possibility of the polynomial construction. Okay, so logically you are knowing that with to create fifth degree polynomial, but by watching the difference column, you can conclude exactly that with the help of 6 points, you will get only third degree polynomial. Because third difference is constant, fourth difference is 0. Looks like derivative, it is working. Is it clear?
Yes, sir.
Now you just pick up the upper diagonal elements and see this formula what I told you. Try to remember that formula again and again. I'll tell you. Okay, y equals to y0 means first value. Y0 in the difference table, first value. Then this value into x minus x0. X0 is the first value of x. And in the next term, x minus x0, x minus x1 in the and next upper diagonal elements. In that way, you just try to rearrange the formula. First value y equals to y0. Y0 is first value of y 48. Then plus x minus x0. X minus x0. X0 is first value of x. Okay. So x minus 4 into this second upper diagonal elements. Starting from y, whole upper diagonal you have to pick up. Okay. Then next term x minus x0 and x minus x1. X0 is 4, x1 is 5. X minus 4, x minus 5 into next upper diagonal elements. Upper diagonal elements is 15 here. Then x minus x0, x minus x1, x minus x7. 7 is means x2. Step by step, all these linear factor you have to multiply, and you have to multiply the upper diagonal, associate upper diagonal elements, and its upper diagonal elements is 1. And another 2 upper diagonal elements I do have, but if I will multiply these 2 0 elements, next terms will be 0 and 0. So I don't consider these 2 terms. Okay. So you just see, this is only 1 factor, here is only 2 factor, here is only 3 factor. So completely in association it will build a cubic polynomial. So with the help of 6 points, you are getting here only third degree polynomial. But logic, scientific logic is that simply we'll give the answer with the help of 6 points. We may able to create maximum what you have to use, maximum fifth degree polynomial, if all the 6 points are lying in nonlinear position. But after constructing this, it is giving you third degree polynomial, means some points are lying in the linear position, means along with the previous point in the joining curve, it is coincide the points. So you are getting here only third degree polynomial. Now you have to use this polynomial and you have to do all the mathematical calculation. Using that polynomial, you have to put in place of x 8. You may able to get corresponding y value, that is the approximate, because these techniques are numerical techniques. So whatever the result you are getting, that is the approximate value. At y equals to values of y at x equals to 8. If you will put in this polynomial, you will get 448. Just see. At x equals to 7, you are getting 294, and at 10 it is 900. So in between 7 to 10, you do have somewhere 8. So 8 value is lying in between these two value, and that is looks like 448, and 448 is also in between these two value. Means data is in increasing way, so corresponding value is also you are getting in that way. And x equals to 15 is, if you will put in place of x 15, you will get corresponding value, and that 15 is at 13 it is given to you 2028, and obviously at 15 it will be, if the data is increasing, so at 15 you will get more than this value, and that is coming 3150, and these two values are approximate. So can you able to use this numerical technique, means Newton divided difference interpolation, with the help of another given set of data points? Main logic is construct difference table, pick up upper diagonal elements, associate or create that interpolated polynomial, and in using that polynomial you just calculate the query points. Clear?
Yes, sir.
Okay. One important thing I would like to mention here. Okay, this is the formula. Okay, this is the formula. Newton divided difference interpolation formula: y equals to y0 x minus x0 f of x0 x1 x minus x0 x minus x1, like that. This is the formula. Now just try to recall your formula of Newton forward interpolation. We just try to recall that in terms of u, we have written somewhere there the formula y equals to y0 u del y0 u minus 1 by factorial 2 del square y0, where u is x minus x0 by h, isn't it?
Yes, sir.
This is the forward interpolation. Okay, and this is Newton divided difference interpolation. Now, sometimes in the question it will be asked to you, theory question or 5 marks, suppose, lengthy question, so that for the equal space arguments, Newton divided difference is coincide or converging with the Newton forward interpolation. Just a minute. Hello. Class में बोलिए. Complete के बाद. Hello.
Yes, sir.
So suppose for equal space arguments, so that Newton divided difference interpolation is converged to Newton forward interpolation. Means if the x values are equally spaced, means x1 minus x0, what is the space length? Suppose this is h, and xn minus 1 is h. Means all values are equally placed, equal space arguments. Then this formula will be same as this formula. Okay. If the x values are not equal space, then you will use Newton divided difference interpolation. That is clear. Clear, and you just keep that idea in mind for lifetime. Okay, if these values are not equally spaced, you have to use Newton divided difference. But by chance your x values are equally spaced, then this formula will be coincide along with the Newton forward interpolation. So for that time, you have to see what will be this value, what will be this value, what will be this value, what will be this value. You just try to calculate for equispace arguments, what it will be. Okay, question is clear?
Yes, sir.
This formula will be converged to this formula for equal space arguments actually. For equal space, now how these operations I am doing actually, let's try to, this is for equal space. Just for equal space arguments, you are seeing this, just see nicely. Suppose x0 and x1, what is the space length, and that is same as xn minus xn minus 1.
Sir,
Means
screen is freezed.
Screen is
Freezed.
Screen is not visible.
Sir, it is freezed.
Freezed.
Yes, sir.
Freezed means paused.
Yes, sir, it paused.
Let me share again. Now tell me, is it visible?
Yes, sir.
So you know divided difference for two argument f of x0 x1 that is f of x1 minus f of x0 by x1 minus x0, and that value f of x1 means x1 is x0 plus h, and I am thinking, or in the question it is given to you, x values are equally spaced. So for this logic is, whatever the x arguments, that x argument is equally spaced means xi minus 1 equals to h. H is the space length for all I. I equals to 1 to n. Okay. So x1 will be x0 plus h. X1 will be x0 plus h. X2 will be x1 plus h. In that way, these values are working, means these values are equally spaced. So x1 is x0 plus h. This is f of x0 plus h minus f of x0. And what is this value in numerator in terms of forward difference operator? That is actually nothing but y1 minus y0 is the del y0. Y1 minus y0 is the del y0. That is, you know. And that is del of f of x0, and that is del y0. And x1 minus x0 is h. So that first divided difference of two arguments is nothing but del y0 by h. So this is nothing but this is del y0 by h. So if I will use for three arguments, second difference, this will be so use this first difference idea here. What will be in terms of forward difference operator? This value del y1 by h, and this is del y0 by h. and this is basically 1h. It's 1 into h, and below it will be, this is 1h, 1h, 1 into h, 1 into h. Then below it is multiplied. When again I will do the calculation, in below it will be 1 into 2, that is I am writing factorial 2 to get a nature of variation in for higher orders. Okay, and above it will be del y1 minus del y0 is del square y0. So that is below it is factorial 2h square. Okay, so similarly for 4 arguments it will be, if I will use this previous difference value, it will be del q y0 by 1 into 2 into 3, that is factorial 3 h cube del q y0. So similarly, step by step for higher differences for n plus 1 arguments, it is del n y0 by factorial n h to the power n. In that way, for the equi-space arguments, the divided difference is linked along with the forward difference operator. And that value, these values are actually, these values are nothing but upper diagonal elements in the difference table or divided difference table. Okay, in these places or in the Newton divided difference interpolation formula, this upper diagonal value, you just use these values. Okay, you will get below formula nicely. So since y equals to y0 x minus x0, what is this? Is I told you this is del y0 by h, isn't it? And this x minus x0, and if I'll consider this denominator h, x minus x0 by h, that is u, then next term will be, first term is y0, next term will be u into del y0. Isn't it? Students?
Yes, sir.
That Newton forward interpolation is clear? This is Newton forward interpolation. It was written there in terms of u, and that u is x minus x0 by h. Okay, so if I will use the divided difference for equal space argument in terms of forward difference operator, this is basically del y0 by h, and that h you just write down in denominator position here, x minus x0 by h. So simply this term remain, x minus x0 by h is u. So next first term is u into del y0. So next term is coming u into del y0. Okay, and this will be del square y0 by factorial 2h square. You just, that h square you just bring here denominator position of these two, x minus x0 by h, that is u, x minus x1, x1, x minus x1 you just rearrange, x minus x1 is x0 minus h by u, sorry, by h, x minus x0 by h is u, and minus h by h means 1, means u minus 1. So first term is u into u minus 1 del square y0 by factorial 2, and that is coming the second term. Okay, in that way you may able to write this last term u minus 1 up to u minus n plus 1 by factorial n del n y0, and that is nothing but Newton forward interpolation for equal space arguments. So can you able to complete this theoretical importance, or if it will be asked to you in exam, can you able to derive this?
Yes, sir.
That is important. You just keep that things in mind. Okay. For equal space arguments, Newton divided difference interpolation is converted to, and to prove it for 5 marks, suppose it will be asked to you. That is also your assignment. And in lab plus for equal space arguments, this is the formula. If two arguments are equally spaced, then limit h tends to 0 f of x you have to take limiting case and it will be linked along with the derivative. That is in the lab, I told you. That is in the lab, I told you. Just try to remember. Otherwise, for the equal arguments, you cannot able to calculate the divided difference. F of x0 minus f of x0 by x0 minus x0. That is 0 by 0 form, indeterminate. So in that case, you have to use the limiting case. You will get a link along with the derivative. And this is also in general assignment. Looks like this. For n plus 1 arguments, it is matched, and remaining arguments is not matched. For n plus 1 arguments matching, for that purpose, you have to do the derivative of that divided difference term, 1 by factorial and ddx of, and you have to consider the separate values. Okay. And in the lab also, that is the assignment I given you. Okay. So I think today your class is over. That file or divided difference file I am uploading in the MS Team. Try to complete divided difference nicely. Okay.
Thank you, sir.
Okay. Your class is over. I am uploading this file in MS Team. You should clear these techniques. Okay. What I told you in the class, on that way, you just complete step by step all the importance. Your class is over. If you do have any query, you may ask. Your class is over. If you do have any query, you may ask. Otherwise, we are ending the meeting.
Okay, sir. Thank you, sir.
Okay, you are welcome.